In this video, I'm going to write the equation of a trig function by looking at the graph. And I never do enough of these in class, so this is a good video to watch. This always catches people up. There's, let's take a look at the, put a video on the screen. Let's take a look at this. Okay, so here's a graph. Hope this works. What's happening? Why is it doing that? I'm sorry, guys. There we go. Okay, so here's a graph. It's a trigonometric shaped graph. Goes up and down. It's either a cosine or a sine graph. It's actually either. And because it's periodic, there's an infinite number of potential equations we could write for it. We're given a series. We're given 3 points. It might be nice to also have this point in the middle here and in the middle here. Notice that our y values go from 1 to 2. So our middle points have a y value of 3/2. And let's see, halfway in between 0 and pi over 2 would be pi over 4, would be our x value for that one. So there's our point for the middle there. And then here, halfway between pi over 2 and pi, that seems like it's going to be 3/4 pi. And also has a y value of 3/2. So fractions are kind of inevitable here, looks like. So we have to decide on a starting point. And we can do different starting points for different equations. But let's use this as a starting point. That seems like a nice, easy starting point. It's a nice integer. It starts at 0, et cetera, et cetera. And therefore, because it starts at a minimum, if a function starts at a minimum or maximum, it's going to be a cosine function. So it's basically going to be a negative version of one of these, right? Now we have the form y equals amplitude times cosine times frequency times x minus h, which is our horizontal shift, plus k, which is our vertical shift. Now, in this case, our vertical shift, our k value, has to be to this midline. All right, always to the midline. So no matter what we choose, we're gonna, whether we choose sine or cosine, doesn't matter. We are going to be doing plus 3/2, because this is 3/2. 1.5 is 3/2. That's our horizontal shift to the midline. Midline, has to be midline. Has to be midline, okay? All right, now, we're gonna need our amplitude. It looks like the total height of this curve is 1, but the total height of a regular cosine curve is 2. It goes from -1 to 1 normally. So our amplitude is 1/2, because 1 is 1/2 of 2. Or we could think of this distance from the midline to a minimum is 1/2. So there's our 1/2. It's also going to be negative because we're starting at the bottom. Our regular cosine curve here starts at the top, but this one starts at the bottom, so it's negative. It's flipped over. Now the frequency. Let's see, the total period here from beginning to end is 1 pi. Total period is 1 pi. It goes from 0 to pi. All right, here's your x values from 0 to pi. So the period here, the period is equal to pi. All right, now we have a formula, but if you think about it, if the period is equal to pi, there's 2 of those in the distance of 2 pi. 2 pi is your basis for your frequency. So there's 2 full periods in the regular period of 2 pi. So the frequency is going to be 2. But we can do frequency is equal to 2 pi divided by period, and that of course equals 2. So there's your f value. which I think I call B typically. I think in our formula we call it B, but it could be F for frequency. And then X minus, let's see, there's no horizontal shift because our X value starting point here is 0. So just X, end all your parentheses, and then plus K is your vertical shift, which you already did as -3/2. Now, we could think of this as a sine graph. Let's think of this as a sine graph for a minute, and let's use this as the starting point, the pi over 4 and 3/2. So if we're going to do a sine graph, we still have the exact same amplitude, but it's not negative because we're starting at a point where the sine graph is starting to go up. So we should erase that little negative part. Okay. Then we're calling this a sine graph. It still has the same period or frequency of 2. It is shifted this distance right here. So it's shifted to the right pi over 4. And then it's still increased by 3/2. All right. So in order to write more and more equations, you need to focus on leaving the, I'll put green for this. You're going to leave the amplitude, you're going to leave the frequency, and you're going to leave the vertical shift, but you're going to change, and I'll make these orange. You're going to change the flip, the potential flip. You're going to change whether it's sine or cosine, and you're going to change the horizontal shift. So you can keep doing more and more of them, just picking new starting points. Starting points that are good to pick, and maybe this is obvious, but I think I should spell it out. Starting points that are good to pick a good color. Pick this washy red, are either maximums, minimums, or midpoints, right? So any of those points could be good starting points to create an equation out of.